Okay. Hello and welcome. This is a basic review on the types of chemical reactions that there are going to be. You will be asked to identify, given a chemical reaction, what kind of a reaction is it going to be on the test or the final exam, whatever. But this should help you guys out a little bit. It's on your own, again, it's on your own time. So, types of reactions, this is in chapter 6.2. Basically, there's 5 different kinds of chemical reactions. There's synthesis, decomposition, single displacement, double displacement, and there is combustion, aka meaning also known as oxidation reactions. So, we're going to look at those 5 kinds. How do we distinguish it? And we go through here and we look at, let's look at this first one here, synthesis reaction. Anytime you see something being put together to make one product, synthesis reaction, automatically. So here's a great example of it. 2H2 plus O2 gets 2H2O. Another way to look at this, if I use letters of the alphabet, okay, A plus B gets us AB. This is a synthesis reaction, okay? That'd be kind of important. So this is an example of a synthesis reaction. We're going to go ahead and erase this, and I'm going to move on very quickly. Then we talk about reaction type number 2, decomposition. Anytime you think about decomposition, you should be thinking breaking apart. Taking Legos and unsnapping the bricks, if you will. That's what decomposition is. So we can look at something like this, where we can take the reverse of our preceding reaction and say 2H2O breaks up into 2H2 plus O2. Another way to look at this is we can take AB and break it down to A plus B. This is a decomposition reaction, and sometimes this is stuff that we need. If we have gold locked in the rock, for example, we can try to extract the gold out of the rock through a decomposition process. We could do that. That's one way to do this. Okay, I'm going to go ahead and erase this. Now, decomposition reactions, you will also find them in nature. Think about bacteria, fungus, breaking down dead things, which is kind of an important thing. Okay, so we're going to skip through those things. We talked a little bit about that, but I think reaction types 3 and 4, single displacement, double displacement, are probably the ones that give the people the hardest time. So this video is really for you guys. Okay, so when we look at something like this, a single displacement, well, let's look at the word displacement. What does displacement mean? You knock something out, you displace it, okay? If I turn around and I displace the camera, I knocked it out, right? I completely knocked it out. And now, of course, I have to bring it back into focus here to make sure that I got everything. And okay, here we go. So we got everything here. So when we look at a single displacement, one element takes place of another in a compound. So, for example, if I use the letters, let's go with A plus BC. So A would represent something like zinc, BC like HCl. So the B you could look at as the H, the C is the Cl. Okay, and now we're combining this. We're doing a switcheroo. That's really what this is. You're switching, you're changing something. So we go from A plus BC, we end up getting AC plus B. This is a single displacement reaction. One thing is being displaced. What is being displaced? B. B is the one displaced. It is kicked out, if you will. Okay? It's kicked out away from the C compound. And again, Why would we have something like this? Well, in this case, when you look at this reaction, here 3 zinc plus copper phosphate gets us 6 copper and zinc phosphate. We were interested in extracting the copper from the copper phosphate, and the only way to do that was to add some zinc. Now, it doesn't tell you the process, like heat, what temperature, how long. It doesn't tell you that. It is just telling you that if you add zinc to copper phosphate, you get copper and zinc phosphate out of the whole deal. Okay? So that would be kind of an important thing. So this is a single displacement. Another way to look at single displacement is you only got one compound here at the beginning and one element. That's a clue. Okay? One element, one compound. One element, one compound. That's single displacement. That's the difference. Now, if we look at double displacement, and I've got to erase this, okay? If I look at double displacement, it is now 2 compounds that are involved. You start out with 2 compounds, you end with 2 compounds, but there's a switching. There's a displacement. I'm not going to move the camera again to show displacement. You guys know what this is. Okay, so what would a double displacement reaction look like? Well, if I use the letters of the alphabet again, A, B plus C, D, and we end up getting CB plus AD. This is an example of a double displacement reaction. Now, because basically what A and C have done, they have switched places in their respective compounds. Okay? How can you tell if this is a double displacement versus a single displacement? In a double displacement, you have 1, 2 compounds. And you end with 1, 2 compounds. In single displacement, you have 1 element, 1 compound. You end with 1 element, 1 compound. That's the key difference between single displacement and double displacement. Okay, let's wrap this up. We got one more reaction type to go over. Okay? All right, tell you what. Let me work on this one here, and let's see if I can write this up. So here is an example of a double displacement. Okay, so AgNO3 plus NaCl, plain old table salt. And what do we end up having? We have AgCl. Notice how it's split. Okay, notice how the Ag, the silver, switch places with the sodium, plus NaNO3. That is an example of a double displacement. The silver switched and the sodium switched. A double displacement reaction, you get 2 compounds. Notice not 1 element and a compound, 2 compounds. So here's a compound, compound number 1, compound number 2. You get compound number 1 changed, compound number 2 changed. That's it. That's it for the double displacement. I'm glad I remembered about doing an example there. Okay? All right. Let's go ahead and let's do the last one here. This is a favorite for a number of students out there, and not necessarily chemistry students, but oxidation. Okay? Anytime you hear the word oxidation, think about that first syllable. Ox. Ox. In chemistry, when you think about ox, you think about oxygen. In biology, if you're interested in biochemistry, you think oxygen. If you think biology in the terms of animals, there's the ox, the animal. But we're interested in the chemistry, oxygen. It's also known as a combustion. When you hear the word combustion, you should be thinking fire. You should be thinking oxygen, because in order for a fire to go, you need the oxygen. Basic fire science. Okay? So it's a substance that combines rapidly with oxygen to form 1 or more oxides. So how is this different than a decomposition reaction where we look at something like this? C3H8 plus 5O2 gets us 3CO2 plus 4H2O plus heat. You could make the argument that that's a decomposition reaction. You could make that argument, yeah, because aren't you breaking down propane, C3H8? Yes, yes you are. However, to be more specific, look at the O2. That's what you need. So propane plus oxygen, and that's the key. That's where you get your combustion. That's where you get the fire. That's where you get the flame. Okay? And we end up getting 3CO2 plus 4H2O plus heat. So a great example of this, okay, a great example here is burning propane and oxygen. You get carbon dioxide and water. That is your example. And down here, here's our lab burner burning fuel. Okay, we're adding fuel plus O2, and we end up getting carbon dioxide, water vapor, carbon monoxide, and the X there is not oxygen, it's just X, think algebra, think of like NO2, NO3, because there are going to be impurities in there. But for what we're looking at the 5 types of reactions. There is the oxidation, also known as the combustion reaction. We looked at the double displacement reaction, where how can you tell that between a single and double displacement? Look at the number of compounds you have. You got 2. That's a double displacement automatically. Automatically. And then here, the next one is the single displacement, where we have one element, one compound. And we get one compound, one element. There was a switch. That displacement, there was a switch. And then we looked at number 2. Number 2 was the decomposition. Stuff that happens in nature all the time. It's kind of important. Okay? Decomposition, and don't forget that happens in our digestive system as well. Okay? How else are you going to digest that pizza that you had last night? And last but not least, synthesis reaction, where we are putting things together and forming new substances. That is so cool. And that's how we are able to create new things, new alloys, new material, new synthetic material. Think about new types of cosmetics, new colors, new blushes, new shades. There's a lot of things involved here with the synthesis reaction. Think about medications as well. Okay, so guys, I'm hoping that this will help you out for the different kinds of reactions that there are. And, well, have a good day. Take care.